All right, let's go to number 3. So number 3, we've got a pretty complicated little function. If you actually looked at the function there, but let's talk. This is a good one for local maxes and mins and those sorts of things. How many local maxes do I have on number 3? Y equals f of x. Got a maximum here and a maximum here, and we'll just have to round off there. I think that's it. So how would I write that? Again, use the function notation. F of what equals what? Looks like f of 2 equals, well, that one's easy, f of 2 equals 6. And then also f of 7 is a local max. And that looks like it is equal to 9.5. Does that sound about right? With me on that one? All right, local mins. Well, minimum-wise, this piece right around the y-axis, it looks like that piece, yeah, that piece is just headed downward, so there's not a minimum there. It just keeps going further and further down. But locally speaking, I do have a couple of those, don't I? I have one right here at the bottom at x is 4, so f of 4. And it didn't look like it was quite to 4, so let's say 3. It's a little bit over 4, isn't it? 4.1. And then we've also got, is there another local min? I think so. You can also have a local min in a corner like that. And there's some other places too, but I think that one is too, isn't it? It's lower than all the points around it. Even though it's a corner, it's still lower than all the points around it. So f of 8. F of 8 is also 1, and is it right on 6, would you say? F of 8 equals 6. Okay. All right. What about absolute? As far as maximum, is there an absolute maximum? Don't think so. We just have to go with what we got here, and this piece here looks like it's headed upward, and so it's going to overtake this highest point here and just keep going and going up. That's what we have to go with, the way the graph is shown to us there. So no absolute max, because that point, there's some higher than that. Either one of those 2 points, because it just keeps going there. What about minimum? Absolute minimum over the entire domain. Well, again, same idea, isn't it? These points are definitely not the lowest point, because you got these points, and then this one just keeps going out like that. So it looks like that keeps going and going. So no absolute minimum. So you won't always have an absolute maximum or absolute minimum. Okay? All right. Now, some of these, before I do number 4, let me mention a couple. I guess you might say other examples. What about this one? I don't have this one graphed for you, but what do you think about this? F of x equals minus x squared plus 2. Well, it's easy enough since we have our graphing calculators, and maybe if we didn't have them, should be able to do that. Really a quick little look at the graph, huh? If you look at the graph of minus x squared plus 2, here's what it looks like. Basically, that point being 2. So what do I have there? Do I have a local max? Sure do. Local max at f of 0 equals 2. Do I have a local minimum? No. Nothing, peaks or valleys there, so no local minimum. Absolute max. Well, it just so happens that point's going to be an absolute max, isn't it? That top point. So we do have an absolute max at f of 0 equals 9. An absolute min, no lowest point, is there? Okay. So yeah, even if you don't have just the graph showing, just graph it, look at it yourself. Think about the graph. What about this one? Cosine. F of x equals the cosine of x. Does that have any absolute maxes and absolute mins? Oh yeah, it's got a lot of them, doesn't it? If you look at that one, it graph-wise, it's basically like this, doesn't it? Cyclical curve like that. And so, yeah, we've got lots of peaks, lots of valleys. So how are you going to handle that one? Well, it's got a peak here at 0, and then what was this peak? Isn't that 2 pi? Then we have another peak. Wouldn't that be 4 pi? And then back at negative 2 pi, negative 4 pi. Sorry. Negative 2 pi is here. That's what I mean. Okay? So I've got peaks at negative the 2 pi's. One way you could say it, and what those would be what? As far as local max, local mins, those would be our local maxes, right? So our local max, just give you a way to denote that. The local maxes occur at the 2 pi. So we can say f of 2 pi n. And of course those are going to be equal to 1, where n is an integer. In 1, in 0, in 2, in 3. That's one way you could write it. All right, what about the local mins? Well, the local mins, they occur at pi, 3 pi, negative pi, negative 3 pi. So it's the odd pi's. How are we going to write that? Well, to get an odd one out of an integer, you need to do 2n minus 1. Something like that, pi. That'll give you odd number. So anyway, just in case you ever come across that, that's one way you can do it. Because if you do n equals 1, you get 1 pi. If you do n equals 2, you get 4 minus 1, you get 3 pi. If you do n equals 3, you get 5 pi. So that gives you the odd pi's. And if you go with negatives, you get negatives. Okay? All right, just thought I'd mention those. All right, let's go to number 4. Number 4 has an interesting one. Because one thing, this is what we're talking about, a specified domain or a restricted domain. You see here, I've got the points here and the point over here at 9, the point at 0. I'm specifically saying the domain goes from 0 to 9. Okay, so that's what we mean by a specified domain, restricted domain, or specified domain. Okay, this is an example of that. And the domain is x from 0 to 9 here in this case. Something like that. So if you've got something that's restricted like that, that's different than the ones we had before, because the other ones we had before were just going out x to infinity into negative infinity, or negative infinity to infinity. Here we're just going 0 to 9. So if you have that, a couple of things to look at. I mean, you can specify it on a regular function, but this also has another issue or two to talk about. What about, is there any local maximums? What happened? I zoomed in a lot. Okay, I didn't mean to do that. that's what I hit, wasn't it? Okay, let's get it back to somewhat viewable here. Okay, is that better? I think it's a little bit better. Put that. Huh? I might need some help. Yeah, here we go. I'll try not to hit that again because that's right in my little corner there. All right. So anyway, what about local maxes and min there? Well, the other issue on this one is this is y equals g of x. I don't know why it's so far up there now, but this is a g of x function. Okay, so yeah, when we have those points that are off the regular function, what do we do about that? Well, let's think about it. The easy one here is this one, right? That is a local max right there at 7, because that's one of our peaks. So g of 7, and that equals 8. Now, you have to be careful when you have those disjointed points like this. Now, it just so happens that this one, we have kind of a peak at 3 here, but we've got that point up there. Is that still a local maximum? It is, isn't it? Because this point, which is the point at 3, is greater than, that point is greater than, that function value is greater than all the ones around it. Isn't it? It is. So, yes, g of 3 is another local max. Now, what's the function value at g of 3? It's 7. Yeah, don't get stuck down here. That's not the function value, because at the 3, we're jumping up to 7. Okay? Local mins now. All right. Well, a couple of things that we do need to talk about with this one. We don't have any real valleys, but there are a few points of interest we might want to talk about. Right down here, as we're approaching 6, coming in at 6, we're coming down here, and it looks like the graph is, and it is, it's still headed downwards here. It doesn't really level off and turn back up yet. And so, do I have a local min there? The way it's arranged, I do not. There is not a local min at 6. Here's why. That's not a local min because I can't say, well, which point am I going to pick here? Because the function jumps right at 6. So what point am I going to pick? Am I going to pick 5.9? No, because at 5.91, it goes down a little bit further. At 5.92, it goes down a little bit further. At 5.99, it's a little bit further down. You see what I'm saying? There's not a lowest point there because this graph, it doesn't look like it's turned around yet. And so this graph is headed downward, the downward trend there. And so there's no lowest point there. And then at 6, it jumps up to be 7. So there is not a local minimum there. There's not a lowest point there because we can always go something that's a little bit lower. Okay? So that's not a local min. What about these? What about the ones on the end? They're low compared to one side anyway. Well, the thing about it is, on these local maximum minimums, you kind of need to know both sides of the story. We don't know what happens over here, and since it's restricted, we're not going to know unless we form our own little graph there, but we can't officially say those are local mins. either. So that's not a local min, and neither is that. So endpoints like that, not going to be local mins, because you don't know what happens on the other side. And that's about it, isn't it? There's not any other points. So one other point let me make real quick here is going back to what was it? G of 3. Yeah. Going back to this one. What if this point I move down here? Is that a local maximum still? If that G of 3 is down at 4.5, it's no longer a maximum, is it? Because this point is lower than this point, and this point is lower than these points. So this point at 3 is no longer a point higher than the other ones, greater than the other ones. Value, function value. So what point are you going to pick here? Well, you get the same thing as you ran into over here. Okay? That would cancel out that being a local maximum. So having that point, where that one point is located, that disjointed point, that's a big deal. If it's below it, then it's a different story. Now, the other thing, too, back to the 6 point here, if this point was not here, let's say that was open circle and this was filled in, would I have a local min there then? I would have a local min there then. Because I could say G of 6 is, that's the lowest point here. There's not anything lower over here because the point then jumps up here, you see, the values. So that one, it would be a minimum. So where that point is, that's important. So just beware of that, okay? All right. I think that's all I did want to say about that. Okay? Question or concern? Okay. Absolute. Yeah, they probably will. Thank you for reminding me about that. Is there an absolute max and absolute min? Over this specified domain. Yes, there is. There's an absolute max at G of 7 equals 8. Because that is the very highest point right here at G of 7 equals 8. It's the very highest point there is for this function. And then on the absolute min, if we're going over this restricted domain, we can say there is an absolute minimum point for the restricted domain. The absolute minimum is it's this point down here, isn't it? G of 0. G of 0 equals 1.2 or whatever it is. Yeah. As far as absolute max and absolute min, you can say there is an absolute lowest point here. It's a little different than the local ones. You don't have to know necessarily what goes on after on the other side there. So yeah. Okay.